Yeah, let's knock out this practice test 24. Not too many more to go. It's crazy. All right, so number one, just ask you, is it geometric or not? Geometric means they're multiplying by the same thing. Their r is the same all the way through. Obviously, to get from 80 to negative 20, they multiply by negative 1/4. From negative 20 to 5, that's negative 1/4. 5 to negative 3/4. Let's check that real quick. When I punch in 5 times negative 1/4, I do not get negative 3/4. So that's a no. It was close into that very last term. Number two, determine the common ratio, the fifth term, and the nth term of that geometric. So they're telling you this was geometric. Remember, to find r, all we do is you put the second term over the first term. So I'm going to put 14/3 over 7, like this. 14/3 divided by 7. And when I do that, well, I'm thinking you can punch it in your calculator if you want to. I'm thinking keep, change, flip right there. So I'm thinking 14/3 times 1/7, which ends up being 2/3 right there. So that's my r, which is the first thing they asked me for. The fifth term, to find the fifth term, you do the first term times r to the n minus 1. So I'm going to do 7 times 2/3 to the fourth power. And so I'm punching that in. And make sure you, when you're a calculator, let's change those to fractions. So I'm putting 1/12 over 81. Then this is the nth term. Nth term, remember, leave the n's in. So I'm going to the first term times r to the n minus 1. So that's the general formula right there. There's the fifth term, and there's r, which is everything they asked for. Number three, these are the ones we did this week. Where it's like, do the math, use what they give you, and do something. It says the first term is 8, which is awesome, and the third term is 2. Find the fifth term. Okay, so if I know the third term is 2, remember this from this week. The third term is the first term times r squared. So that's what they gave me. So I'm going to say the third term is 2, the first term is 8, r squared, which means r squared. If I divide by 8, it'd be 2/8, which is really 1/4, which means r is going to be 1/2. So to get the fifth term, again, here we go, 8. The fifth term is the first term, which is 8, 1/2 to the fourth power. So I'm going to do 8 times 1/2 to the fourth power, and I'm getting 1/2. And that right there is the fifth term. So use what they give you to find what you need to get what you need. All right, that's kind of weird to say, but that's how you go. Number 4, find the sum. First of all, it does not go forever. So the formula here is the sum is the first term times 1 minus r to the n power over 1 minus r. I know the first term. I know I can tell r to get from 1 to 3, 3 to 9, they're multiplying by 3. What I don't know is how many numbers there are. So I'm going to have to go back. 2187 is the last term. Think about that. Last term is an equals the first term times r to the n minus 1 power. So that's really 3 to the n minus 1 power. So what I'm going to do right here, of course, you could do log if you want to, but that's going to take a lot longer. Just take your calculator and go 3 to, let's say, the 8th power. I'm just guessing here, 3 to the 8th power. That's too big, so 3 to the 7th power. And sure enough, that's what it is. So that means n minus 1 must be 7, because it takes, the power's got to be 7 right there, which means n must be 8. So it means that 2187 is the 8th term. So now I can punch it in my calculator. What I know for sure is the denominator is negative 2. So all I'm punching in is 1 minus 3 to the 8th power, getting negative 6560, which I have to divide by negative 2, which gives me 3280. So the sum of all those numbers is 3280. Had to use both formulas though, so be careful there. Number 5 is also geometric because there's an exponent. When you see an exponent involved with a sigma like that, that's going to be geometric. So same formula. This formula right here, the sum is the first term, 1 minus r to the n power over 1 minus r. Now this sigma is always the best because you can find everything really quickly. To find the first term, I'm plugging 0 in for k. And if I do 1/2 to the 0 power, anything to the 0 power is 1. 1 times 4 is 4. So the first term is 4. Then I'm doing 1 minus r. Guys, r is always going to be whatever has the exponent. So it's going to be 1/2. Probably should use parentheses, run 1/2 there for sure for my calculator. N power. N means how many terms there are. Because I started at 0 and go to 7, that's actually 8 terms. And remember, the way you do that, the way you find your n is always 1 sorry, the top minus the bottom, and then add 1. That's why I was saying 1. Top minus bottom plus 1. So I know that my denominator is going to be 1/2. Numerator, typing that in right now. I'm putting the 1/2 in its own parentheses, and then putting the 8th power. And I'm getting something ugly on the top. I'm getting like 3.9843375. And then I'm going to divide that by 2. Sorry, multiply it times 2 because the 1/2 keep change flip. So I'm multiplying by 2. And let's see what happens if I change that to a fraction, if it'll do it. And it will. The fraction I'm getting is 255/32. So make sure. I would do this while you're watching this video. I'd practice punching that in to make sure you're getting it, because those are a little weird to punch in. Okay, number 6, determine whether the infinite geometric series is convergent or divergent. If it's convergent, find the sum. Remember, it's convergent if r is between -1 and +1. So in this case, r, if you're looking at it right here, r is -1/2. That's what they're multiplying by. And because that's between -1 and +1, it means it is convergent. It's definitely convergent. So the sum formula for this one is an infinite sum. You do the first term over 1 minus r. The first term is 1. I'm doing 1 minus -1/2, which is really 1 over 1 plus 1/2, which is 3/2. And 1 over anything is reciprocal at the bottom. It's just 2/3. That's the sum. That's what it converges to. Number 7. This test is kind of backwards. We did actually arithmetic first this week, and it's second on the test, and that's okay. Number 7. So we're doing arithmetic now. Arithmetic says, figure out if it is arithmetic, if so, what's the difference? Now remember, arithmetic means they're adding the same thing all the time. In this case, it definitely is arithmetic because they're adding 6, which means the common difference is 6. Number 8, find the 5th term, 100th term, and the nth term. So of this, it's telling you it's arithmetic. So to find the 5th term, you do the first term plus n minus 1 times d. Because we're looking for the 5th term, n minus 1 is 4. The difference is also 4, so just add those up, you get 17. Then it says find the 100th term. The 100th term is the first term plus n minus 1, which would be 99, times d, which is 4. So I'm doing 99 times 4 plus 1, getting 397. And last thing it says is find the nth term. And remember, when it says find the nth term, you leave the n in. So I'm doing 1 first term plus n minus 1 times d. D is 4, and you're fine to leave it just like that. That's called standard form of arithmetic, so you're good to leave it. Number 10, find the sum. Now, this is arithmetic. Look at it real quick. They're adding the same thing every time. They're adding 5. So the way you find sum of arithmetic is you do, this is the formula we're using, number of numbers over 2, first term plus last term. What I know here is I know what the first term is 1, and the last term is 91. What I do not know is what n is. Anytime you don't know one of those terms, like how many numbers there are, or the a1 or the an, go back to your old formula and do an equals the same thing we just did. The old formula, this one, the an equals a1 plus n minus 1 times d. So an means last term. The last term is 91, equals the first term, plus I don't know n. D, though, is 5. Can tell that by looking. Move the 1 over, that's 90, equals n minus 1 times 5. Divide by 5, run out of room there. 90 divided by 5 would be 18. And then move the 1 over and get 19. There's my n. So 19 goes right there, back in the formula. Now I'm going to do 19 divided by 2, which is 9.5, times 92. I'm getting 874. That's the sum. Quite a bit of work on that one. So, yeah. Number 11. Sigma's awesome because you have everything. And I know it's arithmetic because that right there is like slope-intercept form. It's linear, so you know it's going to be arithmetic. So I'm using the same formula. Sum of n. Now, n, remember the trick I told you a minute ago. Top minus bottom, add 1. Top minus bottom plus 1. 20 minus 0 is 20 plus 1 is 21. That means there's 21 terms. The first term, the way you get the first term is I'm plugging in the 0 in there. And if I plug in 0, I just get 1. And the last term, the way you get the last term is you plug in 20. 20 times 20 is 400. 1 minus 400 is negative 399, which is pretty big. So I'm going to punch that in real quick. Well, it doesn't matter. Having a hard time punching this in. Sorry about this. This is live TV, so bear with me a second. Okay, I'm getting negative 4,179. And again, I would work on punching that in my calculator if I were you. Number 12, solve this thing. When you're looking for exponents, you're probably going to be doing logs here, which you are. So I'm putting the exponent in the front. So I'm going to use natural logs. You can also use log logs. Doesn't matter. It's your pick. Because of that x minus 1 and because I have x's on both sides, I'm going to distribute the natural log 9 like that. I need to get the x's on the same side, so I'm going to bring that natural log 9 to the other side. Just like that. Now to get the x, got to factor out that x, which would leave me natural log 7 minus natural log 9 equals negative natural log 9. Now remember, you can't subtract logs. You actually do division, so I'm going to make that 1 log and make it log 7/9. And then to finish up, I'm going to have to divide, to get the x by itself, I'm going to divide both sides by natural log 7/9. I'm going to punch that into my calculator exactly like you see it. Make sure you close your parentheses for your logs. Let's see, natural log 7/9, close that one too. I'm getting 8.7429. And again, you can take that answer, and this on Friday, I'll take that answer. You can plug it into both sides of your x's, and you should get the same thing on both sides when you check it. Number 13. 13 has a log equation. And again, it's got addition. Remember, we can never add logs. Whenever you see addition, that means you're going to multiply. So on this side over here, I'm going to do FOIL. I'm going to get this, we're going to do FOIL. This side still is 1. Now there's only one log. Anytime you only have one log, you always do, you already got the log. You do the log thing. You take the base, which in this case, even though it's not written there, is 10. So I'm doing 10 to that power equals that. So I'm going to put x squared minus 2x minus 15 equals 10 to the first power, which is 10. I'm sorry, the base is 9 on that problem. I just now saw that. I forgot to write that in the first part. That's a big difference. So let me fix that real quick. That should be a 9. That should be a 9. 9 there. 9. I was about to say, I started looking at it and I was like, that's not going to factor. So this will make it factor. Move the 9 over, we get 24. Now we can factor it, x minus 6x plus 4. So I get 6 and negative 4. You got to check these. And all you got to do is check and make sure the log's still positive. If I put 6 in there, 6 is great. If I put negative 4 in the first one, it's already negative. It's also negative there, so negative 4 does not work. It's x equals 6. 14. A radioactive substance decays in such a way that the amount of mass remaining after T days is given by this. It's giving you the formula to use. Find the mass at time 0. So I'm just going to plug in 0 in for T. And if I do that, the whole exponent becomes 0, which means I really get 6e to 0 power. Anything to 0 power is 1, so it's really 6 times 1. So it's 6 kilograms initially, or at time 0. Then it says how much is after 20 days. 20 just means I'm going to plug in the 20 for T. That's the time. So it's really more of a calculator problem. Anything else? I'm just plugging the 20 in right there. I'm going to do that real quick. 6 times e to the negative 0.087 times 20 power, getting 1.05 kilograms. 2 more. Number 15. Graph, tell the asymptotes, domain, range, all the things. So I can factor the numerator like that, and the denominator's there. So here's what I know. The vertical asymptote, whatever makes the bottom 0, x equals 2. Horizontal asymptote, this time, remember there are 3 rules. This time the degree is the same, so you do leading over leading, which is y equals 3. My x-intercept, so whatever makes the numerator 0, which is 1. My y-intercept, put zeros in for x's or cover up your x's, and you get 3/2. So I'm going to put that on my graph right here. Let's see, the vertical is x equals 2. Right there. Horizontal y equals 3. My x-intercept is 1. The y-intercept is 3/2, which tells me one thing I know already is that the graph the curves goes this way. To find the other side, I'm going to just punch in the calculator real quick. So I'm punching. I always you punch in the original. Make sure you're using parentheses around your numerator denominator. Graph it. And my other on the left side, the graph is up here. It also asks you for domain and range. Don't forget that tomorrow. Domain is how far left and right it's going. It's going left and right forever, but it's skipping the 2. It always skips the vertical asymptote for your domain. The range is how far up and down it's going. It's going up and down forever, but it skips the 3. Your range will usually mirror what your horizontal asymptote is. Last one, find the zeros of this thing. Now, one beautiful thing about this problem is the last term is 1. So my list is going to be plus or minus 1 because you put the factors of the last number over the factors of the first. They're both 1, so we're looking good there. So what I'm going to do is I'm going to take my calculator, I'm going to punch this in and graph it and see if it crosses at 1 or negative 1. And it looks like it crosses at 1. So but you have to prove it. So you put the 1 in the box. Let's see, you remember if it really is true, that means I'm going to get a 0 here. Bring down the 1, multiply, add, multiply, add, multiply. Yep, works out great. It leaves me this, by the way. It leaves me x squared minus x plus 1. Now, the bad thing about this one, it says find these zeros, which means find all of them. There are 3 zeros because it is degree 3. I can't complete the square here. That won't factor, so I'm down to x equals negative b. So here goes x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So work out what's inside there. What's inside is square root of negative 3 all over 2. So to finish up, find all the zeros. You need to take an I out of that square root because it's negative. And don't forget the first answer you found was 1. And there's all the zeros. All right. Sounds good. Hope that helps. Wear this video out if you need to. Hope you do great tomorrow. See you then.